Hello, everybody. Mr. Barry here, for Algebra 2, the week of May 4th, 2020. And we are going to be talking about systems in three variables. So hopefully you already watched the video with the visual representation of that. I think the video went pretty well with that. And what we're doing here is we're moving last week's review of Algebra 1 and system of equations to now this week, where you're going to see our systems have not only three equations, but three variables in each of those, well, most of those equations. So in this specific video, what we're going to do is we're going to talk about the beginning of the problem and talk about what would be the most efficient way to start solving a system in three variables with elimination. So just to start us off here, we had a good representation on that YouTube video of how it looks visually. Algebraically speaking, we would see something like this, where we see three equations and three variables. So in this particular video, what we're going to be looking at is how to kind of start this off. So our first couple steps here would be, in order to start this problem off, we have three equations here, and we want to take it down to two equations. And as that kind of goes, the same could be said, hopefully, in the most part, with the variables also. So kind of like what we did last week with elimination, our hopes here early on is to eliminate one of the variables. And which variable that is, it doesn't technically matter. What I'm going to do here is explain to you, hopefully maybe some shortcuts to figuring out which variable would be the easiest one to get rid of first. So we're going to eliminate one of the variables. And like before, our hopes here is, in order to eliminate, we would like to find opposite coefficients as much as possible. Kind of like we did last week when we did elimination also. So if we can find opposite coefficients, that will make it really easy to eliminate certain variables, because then we just add the two equations together and their opposite coefficients. We'll be able to do that a little bit quicker than possible. Now, you do see up here three equations. Just also what you'll see within these problems is some sort of labeling mechanism. From teacher to teacher, it could be different. You might see an equation, the equations labeled A, B, and C, or you might see them labeled 1, 2, or 3. For this video, just for what I'm used to, I'll probably just label them A, B, and C to start off with, and you'll see why that's important here in a moment when we start doing the examples. So let's go ahead and try to do the first examples here. It says, which variable would make the most sense to eliminate first in this particular problem? So I have this example 1, and what I'm going to do here, which may or may not be a good idea, once you get rolling on this, you might not need to do this, but what I'm going to do is I'm going to kind of take a look here and see, take a look at the coefficients in front of the variables, because if there are opposite coefficients or coefficients that match up pretty easily with multiplication like we did last week, that might be our best bet. So very quickly, let me start off by labeling these equations so that when we talk about them, we know what we're talking about here. So there's A, B, and C. And then I'm going to take a look at the variables. So for instance, the variable x here. If you look at all the equations, in equation A, the variable is -1. In equation B, it's -5. And for equation C, it's 2. Now, there's not necessarily a factor within that set of numbers, which means, like, if I try to take the number 2 and put it in the -5, there's nothing whole number integer-wise that I would take that. And my quickest factor for x there would be a 10. So I'm going to go ahead and talk about the y's now. And if we take a look at the y's, we have a -5, a -5, and a +5. Now, hopefully from that and what we did last week, you can understand that you see opposite coefficients there. There's a -5 in certain places. There's a +5 in certain places. So far, I would say since we're looking for opposite coefficients, or the quickest way to get opposite coefficients, that's kind of like the leader here in the clubhouse to start off with. But I do want to check out my z's, just to take a look at them. My coefficients for z are 1, 5, and -3. And again, they're pretty simple with 1 and 5, but you can see 5 and -3. Those two things aren't necessarily, I can't take a -3 and easily get it to 5 with multiplication. I would have to work a little bit harder with that. So I'm going to stick with the letter y in this particular case because I already see opposite coefficients. Now, I want to match up those opposite coefficients as quickly as possible in order to eliminate one of the variables. So in this particular problem, I'm going to eliminate the y first because I have those opposite coefficients. What I'm going to do here is I'm going to match up two different sets of equations. And what I'm going to do is, let's say, I'm going to combine A and C. And when I have that written down, I have -x minus 5y plus z is equal to 17. And I have 2x plus 5y minus 3z is equal to -10. And using that elimination method that we did last week, and we're just adding these two equations together, stacked on top of each other, it looks really nice for us. When I do that, I would have -x plus 2x. That would give me 1x. The -5 plus 5y would be 0y. So that would be that location where things are going to eliminate. I have z minus 3z, which was -2z. And I have 17 plus a -10, which would be 7. Now, I'm going to leave that equation there. In the next video, I'm going to talk to you about how to go further with this. But for now, that's a good step to have there. And I'm actually going to take the moment and label that a new equation, and we're going to call that D because we're going to use that later on. Still need to take 3 down to 2. So I'm going to go back to the equations I have at the top. And now what I'm going to do is I'm going to take a look at the two equations B and C. So I'm going to just write them down first. -5x minus 5y plus 5y, z, excuse me, a lot of 5's here, is equal to 5. And then I have 2x plus 5y minus 3z is equal to -10. And using our elimination method from the previous week, again, you can hopefully see that when we add these two equations together here, -5y plus 5y, that makes 0y, which would make 0. That's going to be eliminated. So go ahead and finish this out. So it hopefully makes sense to you that the reasons why I chose AC and BC is because that gave me my opposite coefficients. I was able to look at -5 and +5 and eliminate those. I was able to look at -5 and +5 and eliminate those really, really easy and really simple. I'm going to go ahead and label this green equation down here E. We're not done with this problem. We haven't solved for any of the variables, let alone the whole set X, Y, and Z. So I'm just going to stop there for that specific problem, and we'll talk about that in another video to finish it up. Let's take a look at the next example. Again, we're just looking at the early parts of this and how to do at least the first couple steps. I'm going to take a moment to label these, and if you were somebody who would like to label these 1, 2, and 3, this would be your best say why you should do that, because we have variables A, B, and C, but that's okay. We'll just keep it common for now, and we'll use equations A, B, and C also. I'll go ahead and just write down my coefficients for the letter A. My coefficients are 4, -2, and -1. For B, my coefficients would be -3, 5, and 2. I'm just working my way down in the different equations. And then finally, C, we would have 5, -3, and -4 as the coefficients. So if I take a look at my three options here, trying to figure out what should I eliminate first, I want to think to myself, using that elimination method from last week, what would be the easiest way to kind of decide which one I'm going to eliminate with. What I would suggest to you is that A, the letter A, the variable A, has 4, -2, and -1, and that -1 is really where I'm focusing because it's going to be really easy to multiply that equation by 4 to get a -4, which would be opposite coefficient, to multiply it by a -2 actually to get a +2, which would be opposite of the -2. So if I have all these different equations and the coefficients, and there's only one coefficient that has a 1 or a -1 involved with it, that's kind of where I'm honing in on. So it's not that I couldn't do B and eliminate that first. It's not that I couldn't eliminate C first. It's just quicker to try to eliminate A first. So I'm going to be focusing on the letter A. And I'm going to use that -1 to my advantage. So again, I'm going to write down, and we'll take a look here at A and C. I'm going to use C twice here, equation C that is, because of that -1 coefficient. So I have 4A minus 3B plus 5C equal to -3. My C equation is -A plus 2B minus 4C is equal to -1. Now, right now there are no opposite coefficients. However, with a quick multiplication to the equation C, we're going to go ahead and multiply every single thing there by 4. Hopefully you can see now that our A's have opposite coefficients, and then we'll be able to kind of use the elimination method and get rid of A here. We'll have positive 8B, we'd have -16C, it's equal to -4. I like to kind of just cross that out so I'm no longer looking at that. And now I can see 4A minus 4A, that would give me 0A, which would eliminate out, which is fantastic. That's what we're trying to do here. -3B plus 8B would be 5B. 5C minus 16C would be -11C. And -3 minus 4 would be -7. Again, once I get this done and I eliminate the A here in this set, I'm going to give that another label of some sort. So if you're using numbers, it would technically be equation number 4. If you're using letters, here it's equation D. I'm going to again take a look, and I'm going to use C. Why am I using C so much? Because it's got that -1 coefficient that's really easy to manipulate. So here I'll do B and C. And I'll go ahead and write B down, -2A plus 5B minus 3C is equal to 11. And again, jot down equation C. I don't have opposite coefficients there. However, we know we're trying to eliminate the letter A. So I need to manipulate that equation and get, in B, it's -2. So I need a +2 right here. So I actually have to multiply everything by -2. If I multiply everything by -2, that gives me a +2A, which hopefully you can kind of see will be an opposite coefficient. And we'll do it the whole way down the line. Got to make sure we do it to everything here. -4C times -2 was +8C. And again, I like this to kind of wipe this equation off so that I'm not looking at that and using that as a part of the rest of the solving of this. Again, eliminating that, -2A plus 2A would be 0A, which makes 0. 5B minus 4B would be 1B. I have -3C plus 8C, that's going to be +5C. And then 11 plus 2 would be 13. And I have another equation. We've eliminated A there, but I still have a B and a C in that equation. And I want to go ahead and label it E. I'm not done with the problem. That's just the first step. And we'll get to that in another video, but we're just kind of practicing on how to do this, the first couple steps here. For 5, again, let me go ahead and just, or excuse me, for 5. For example 3, let me go ahead and label these. There's A, there's B, there's C. We're back to variables X, Y, and Z, so it's a little bit easier to use A, B, and C for equations. Coefficients for X, 2, 1, -3. Coefficients for Y, I have -1, 2, and -4. And then finally, coefficients for Z, I would have 1, 2, and -3. Each set of coefficients here, the X, the Y, the Z, they all have some sort of form of 1 appearing somewhere as a coefficient. This example here is just to kind of show you that you could pick any variable you would like to eliminate. You just got to use multiplication sometimes to manipulate them to make sure you have opposite coefficients. Just because we got rid of the first variable and the first problem and the second variable and the second problem, I'm just going to choose to get rid of the third variable here, which would be the letter Z. Again, you could do it any way you'd like, but I'm going to go ahead and choose Z here, and I'm going to really focus on this equation that has the 1 in it, because I'll be able to manipulate that really easy to get opposite coefficients. So I'm going to reuse that 1 a bunch of times, which is in equation A here. So let me go ahead and write this down. So equation A, 2x, I'm going to use A and B here. We got 2x minus y plus z is equal to -1. And I'm going to do B, which is x plus 2y plus 2z is equal to 5. Now, again, I've made a decision to eliminate the z's. That's just, again, you could pick whatever you want here. I'm just picking z in this particular case because it has that +1 there for a coefficient. So in order to get rid of the z's here, what I would need to do is make sure I have a -2z right here. So I'm going to have to multiply this whole equation by -2. Some technical difficulties there. All right, let's try it again. So I'm going to multiply. I got -4x. I got a +2y. I have a -2z. And I have a +2. I'm going to go ahead and just cross that out. And we'll combine the two equations using addition. -4x and 1x would be -3x. 2y plus 2y, be careful there. They're the same coefficient, not opposites. -2z plus 2z, that's my 0 z. So I'm just going to eliminate that out. 2 plus 5 would be 7. I have another equation that I just created. We'll label that D. Again, I'm reusing A because it's got that coefficient of 1 for the Z. So we'll go A and C in this case. I used A and B, so I got to use A and C now. And let me write down A and C. 2x minus y plus z is equal to -1. C is -3x minus 4y minus 3z is equal to 2. Already made the decision. I'm going to eliminate the z's first here. I need opposite coefficients. Right here is a 1. There's with -3. So in order to get an opposite coefficient, I'm going to go ahead and multiply this equation by 3. Every single thing. So there's 6x, there's -3y, there's the +3z I really need, and then there's a -3. I'm just going to go ahead and cross that out just to kind of let myself know I'm done with it. Add up. 3x, -7y. 3z minus 3z would be 0z. I'm eliminating the z's here. -3 plus 2 would be -1. I've created that new equation with eliminating the z's, so I'm going to go ahead and label it with E. So again, just to kind of clarify, we've done the first opening steps to this. The next video will have the same exact examples with just kind of continuing the process and making sure we finish this up.